In this video, we are going to introduce a new distribution called the Cauchy distribution, which will say a random variable has Cauchy distribution if it has density fx equals 1 over pi 1 by 1 plus x squared for all x in R. That it is a density is quite easily checked because it is non-negative, and the total integral from minus infinity to infinity may be obtained using the standard indefinite integral. That integral of dx by 1 plus x squared is tan inverse x plus arbitrary constant. So just put it here and you will immediately see that the constant needs to be 1 over pi. If you plot the density, it looks like this, centered at 0, and because x occurs as x squared, so it is an even function, symmetric, has its peak in the center. As x goes towards infinity or minus infinity, this thing goes towards 0, so it is tapering off like this. It looks pretty much like the normal distribution, except that these tails are much thicker than normal. This distribution occurs in certain physics setups in terms of diffusion of light and spectrum of lights and things like that. But the main reason why probabilists are interested in the Cauchy distribution because it has some weird properties, and so it serves the purpose of counterexamples in various cases. So let us face the first shock with the Cauchy distribution. We shall try to find out its expected value. So we can just apply the definition. X times the density, this 1 over pi being a constant, goes out of the integral sign. Now you want to integrate this from minus infinity to plus infinity. You might be tempted to think that since it is an odd function and we are integrating from minus something to plus that same thing, so the integral should be 0. But there's a problem. What you are integrating here, this thing, has a graph like this. So it's an odd function. So when you say that since I am integrating over something which is symmetric around 0, so the total integral must be 0, you are thinking in this way. Whatever is this integral, this must be exactly negative of that. So when I add, it is something minus itself, so it will be 0. But the problem is here it is going all the way up to infinity, so it's an improper integral. So it's quite possible that this one is infinite, in which case this will be minus infinity, and infinity minus infinity is not 0. If it is finite, then your intuition will be correct. So we have to check whether this thing is finite or infinite. So for that we focus our attention on only this part. We can of course forget about this for this purpose. Now the derivative of the denominator is essentially the numerator, except that I can supply a 2.5. So I see that that thing is log of 1 plus x squared, this half remains here, from 0 to infinity, and you can easily see that when you try to take x towards infinity, this thing will blow up to infinity. So this total area is infinite, so this idea of this cancelling that will not take place. So we get the theorem, expected value of x is undefined. So you already start getting some taste of the weirdness of Cauchy. This is just undefined. What can you say about expected value of x square? Obviously that will also be undefined, because if I put a square, the thing will become only higher out there. So if this area is already infinite, something larger would also be infinite. So it is not just for x or x square, for any moment. Expected value of x to the power k, the kth raw moment, is undefined whenever k is odd, because we will end up with infinity minus infinity situation. And if k is even, then of course it cannot be undefined because it's a non-negative random variable. It will be infinite. So none of these moments exist finitely for the Cauchy distribution. However, here is a theorem which is quite reassuring. If x is Cauchy, then its characteristic function, that happens to be pretty nice. It is e to the power minus absolute value of t for t in R. Characteristic function, of course, must exist. That is this function. In the next video, we are going to take a look at possibly the most shocking thing about Cauchy distribution. But first of all, let's familiarize ourselves with the definition of Cauchy by working out one simple exercise. In this exercise, I am first reminding you the Cauchy density, and the problem is if x follows this density, in that case find probability that absolute value of x is less than or equal to 1. In other words, if this is the density curve, I want you to find out the area between -1 to +1.